Hi, we are going to just have a quick look on IPv4 header. Okay, so this is the IPv4 datagram header format. If you can see, you can have the minimum header size and the maximum header size I have been given along with the payload, which is called data. So here you can see there is a version field, header length, type of service, total length, identifications, followed by reserve fields and don't fragment and more fragment fields, followed by a fragment offset, and then you have a TTL field, protocol field, and then header checksums, and then you have a source IP and destination IP fields, followed by options and padding, which is for uh, optional field size in which you can add up pad it up to ensure the data has been completely created, modified, and then sent across the network, and then followed by the payload, which is called the data. So if you take, you have a 4-bit version field in which it will represent the version of the IP header, which is here it's an IPv4 header, and the header length is a 4-bit field which represents the length of this header, here the 20-byte header, and the type of service is an 8-bit field, which is a class of service field which is going to represents your classified your traffic, IP traffic, and then the total length is the length of the whole IPv4 header, that is the total length. It may be 60-byte header. Okay, and then identifications field, total length is not the header as well, it's the complete packet size that represents the total length, which is a 16-bit field. Identification field is a 16-bit field which represents the uh, packet at the destination end. So how, suppose you are sending a big packet size, okay, it will be fragmented and sent across the network. While it reaches the destination end, it will resize or refragment, or it needs to identify which is the first packet, which is the second packet, so that they can add it up and ensure they will be able to read the correct data size, data format. So to do this process, this identification field has been used. So each and every fragment that has been chunked at the source side will be named with the identification number in this field, and once each and every packet reaches the destination device will be able to identify the first packet, second packet, and then they will be able to rearrange using the fragment offset field, which is coming next. So this DF bit and MF bit is the of course the reserve bit is a reserve bit for experimental purpose, it's a null bit, and DF bit and MF bit is a don't fragment and more fragment bit respectively. This is about the fragmentation process. Okay, DF bit means if this bit set, that means that packet has been not been fragmented, that is don't fragment. If MF bit is set, that means that packet has been fragmented and it expects the next fragmented size packet. So that's what these fields represents. And if you take time to live, this is again a TTL value which represents the life cycle of this packet. It is an 8-bit field where you can see the value of the TTL, and the protocol field is the full P field in which you can see the protocol number which this IPv4 carries. This is an 8-bit field, and the header checksum is the checksum which is done for this IPv4 header, not for the payload. Okay, suppose you are sending a packet from source to destination, this will be validated and the CRC check will be done only for the header of this packet, that will be represented here in the header checksum 16-bit field. And the next two fields are source IP and the destination IP field. Of course the 32-bit IP address will be represented here at the source end, and the destination IP address will be there in the destination field. Options and padding, I didn't mention it here in the padding, but padding is the process in which you can ensure all the fields are occupied before sending this data or before sending this packet datagram across the network by filling it dummy. Okay, that is 0 to 40 bytes, and followed by that a payload, which is also called data here. So that's how a data has been encapsulated using this IP header and then sent it across the network to the destination. So hope this particular slide will help you to identify each and every field of the IP header format and what are the purpose of this each and every field in the IP header. Thank you so much.